Welcome to Brain Vision.
In this problem, we have a boat of given mass which is powered by a fan which develops a slipstream with a given diameter. The fan ejects air with a given velocity measured relative to the boat, and we want to calculate the initial acceleration of the boat given all these parameters. So firstly, we'll use the equations of steady flow. Now the boat initially is at rest, so Vb, which is the velocity of the air when it comes out of the fan, is equal to V of A relative to B, and this is 14 meters per second when the boat is at rest. We also know that the flow rate of the air Q is equal to the speed of the air at B times the area of the fan, the surface area, and this is 14 meters per second multiplied by the cross-sectional circular area, which is pi over 4 times diameter of the fan, 0.75 meters, and that's squared. And so we get the flow rate to be 6.185 cubic meters per second. The mass flow rate, which is dm dt, so the above was the volume flow rate, the mass flow rate, dm dt, is equal to rho a, the density of air, times the volume flow rate. And this is 1.22 for air into 6.185, and hence we get the mass flow rate to be 7.546 kg per second. Now, if we apply the equations that we know, we get that the sum of all the horizontal forces in the x direction, that is equal to the mass flow rate, dm dt, times the speed of the air, the x component of the speed of the air at B, minus the x component of the speed of the air at A, which is in front of the fan. And so minus F, which we get from our diagram, minus F is equal to the mass flow rate 7.546 into minus 14 minus 0, VA is 0, gives us a force acting on the boat of 105.64 newtons. So we found the force that is acting on the boat, and this force causes an acceleration. Now we also know from Newton's second law, we take the right direction as positive, that the sum of the forces of the resultant force acting in the x direction must be responsible for an acceleration, and that the sum of the forces in the x direction must equal to max. The forces we calculated to be 105.64 newtons, and this is equal to 200, which is 200 kg, the mass of the boat, times the acceleration of the boat which you wish to solve for. And so we can rearrange this equation and find the acceleration which the boat has is 0.528 meters per square second.